is now being recorded.
Members of our research team, I am the National President and CEO for the nationwide American Lung Association, and each of you have been invited to join us for this exclusive opportunity because you've demonstrated a passion for our mission through your generosity and also your loyalty to our organization. And I personally want to thank you for making this commitment in supporting the American Lung Association. We'd like to let you know that we take the stewardship of your contributions very seriously. In fact, I'm proud to report that 88% of every dollar raised by the American Lung Association goes directly to support our mission efforts through research, advocacy, programs, and services provided through our health education services. And 88% of every dollar is high by any standard. Everything we do is built to achieve the urgency of our mission to save lives by improving lung health and preventing lung disease. This, along with our vision of a world free of lung disease, drives us each and every day. And with your help, we take pride in knowing that our work is making a difference in the lives of those who literally struggle to breathe because of their lung disease. For over 110 years now, the Lung Association has been funding research, which has been one of our key cornerstones of our work, dedicated to find better treatments, early detection, and ultimately new cures. This is really urgent, life-saving, life-changing work, and you are helping to make it possible. From all of us at the Lung Association, and more importantly, from those that we serve, a heartfelt thanks. You have made our mission your mission, and we are very grateful. We have a lot to share with you today, so at this time, I'd like to turn our program over to Dr. Norm Edelman, our Senior Scientific Advisor for the American Lung Association, and also a Professor of Preventive Medicine, Internal Medicine, and Physiology and Biophysics at the State University of New York at Stony Brook. From 1996 to 2006, Dr. Edelman also served in a dual capacity as Vice President for Health Sciences and Dean of the School of Medicine at Stony Brook. Having worked with the Lung Association now for more than 30 years, Dr. Edelman has been involved in the development of both the research programs you will hear about today, and Dr. Edelman also speaks often for the American Lung Association, representing us on important scientific and medical issues. Now I'd like to turn it over to Dr. Edelman. Dr. Edelman?
Thank you so much, Harold. I really appreciate that introduction, and I really appreciate the opportunity to make this tiny presentation. Actually, I'm proud to do it. As you will hear in my voice, I and indeed all of the American Lung Association are extremely proud of our research program and extremely proud of its accomplishments. And I think after this small presentation, you will agree that we have done very, very well. Now, may I have the first slide? So this is a picture of our research portfolio, a bird's eye view from 35,000 feet. And we have two major product lines, or two major avenues in which we conduct research. The first we call awards and grants, and that means that investigators make applications and compete for these grants, and I must say it's very highly competitive. We only fund about 20 or 25% of submitted grants. We wish we could fund more. And under awards and grants, we have two subsections. We have what we call a career ladder, and I'll go into a little more detail about that in the next slide. And then we have special focus and joint programs, and we've listed some of them here. We have Research Innovation Lung Cancer in Women Awards. This reflects the American Lung Association's new and important interest not only in lung cancer, but in the special problems, both scientific and other special problems of lung cancer in women. We have a joint award, the American Lung Association and the Allergy and Asthma Foundation in allergic respiratory diseases. This is primarily asthma. And this is an award of substance. This is an award which attracts the very top scientists. And we have a joint award with the Longevity Foundation, which focuses on lung cancer. Now, in addition to all these awards and grants, we have something that is very special. We have the Airways Clinical Research Centers. This is a network of 17 centers in, as you'll see, in all the best institutions, which conducts large trials of, which we call clinical trials. Trials of how to diagnose asthma and COPD, and more importantly, trials to how to treat asthma and COPD. And as you see in a couple of slides, this clinical research center network has made a huge impact on the care of patients, first with asthma and now asthma and COPD. So if I could have the next slide, please. Now I would like to talk about the awards and grants. And at the American Lung Association, when we talk about our research initiatives, we have three major categories, or three major flags to look at. We talk about niche, we talk about leverage, and we talk about focus. And this is important because we want to make the absolutely best use of the funds we have available to us. So we look for a niche, we look for a problem, an area which needs additional support, which somehow is important but has fallen through the cracks. And the niche for awards and grants are starter grants to investigators in training and new investigators. This is an area which tends to be neglected by the large funding agencies. It's a critical area. One of the most difficult problems in research in general, but in lung research too, is sustaining our initiative by getting new clinical investigators involved. And so the niche gets people up and going. Leverage is critically important. Now, come back, please. Come back. Thank you. Leverage is critically important. We want American Lung Association dollars to generate many, many more dollars in support of research. And you can see that with regard to the career ladder, we've been exceedingly successful. Our investigators, 85% of them go on to successful research careers. And over the early parts of their careers, we have found that they generate almost $37 for every dollar of American Lung Association support. So we are indeed leveraging our research funds. And the Awards and Grants Program has focus. It's largely focused on the basic and translational sciences. That is laboratory work which is directly related to the diagnosis and subsequent treatment of disease. If you look at the ladder, if you start at the bottom, we fund lung health dissertation grants. These are for doctoral students, largely nursing students. We very much would like to see doctoral trained nurses doing lung research. The next step is the training fellowship. These are postdoctoral trainees. They've gotten their MDs and PhDs, and they're doing research training, and they critically need support to get up and going. The next step is the junior level scientists. These are people who've gotten their first appointment, usually in a university, and they need support to get some data to get going so they can apply for larger grants from larger funding agencies such as the NIH. And the highest award we have is the Lung Cancer Discovery and Allergic Respiratory Award. This is for mid-career scientists This is to attract the very best people into this area of research. Next slide, please. Now let's talk about the Airways Clinical Research Center. The niche is critical. These are practical questions in patient care, which because of the kind of questions they require a large group of subjects for clear answers. And these are the kind of practical and important questions that are not usually funded by the National Institutes of Health or the pharmaceutical industry. We have leveraged American Lung Association funds very, very well in this program. So approximately for every dollar of American Lung Association support, this network generates $1 of outside support. The outside support has come from multiple grants from the National Institutes of Health and also from the pharmaceutical industry. This is something we're very proud of. Our questions are broadly relevant both to research entities and commercial entities. The focus is asthma and COPD. And if you look at the map, this is not a political map. Red is not Republican, blue is not Democrat. Red are the states where we have centers, and you see the dots. It is pretty well distributed throughout the country. Is that the last slide? Next slide. Last slide. So it's now my great pleasure to introduce to you Dr. Robert Wise. Dr. Wise is director of the Coordinating Center of the ACRC, the Airways Clinical Research Centers Network. He's a professor of medicine at the Johns Hopkins School of Medicine and serves as director of research for the Division of Pulmonary and Critical Care Medicine at Johns Hopkins. Dr. Wise is an extremely accomplished investigator in the area of asthma and COPD, and just to put it succinctly, he's the critical cog in our wheel. He's the guy who makes everything work. Bob?
Thank you very much for that kind introduction, Norm. So I will tell you a little bit about the ACRC. And just to set the table, I want to just emphasize the importance of asthma and COPD. Most of you who have contributed to the American Lung Association probably know this, but asthma is a disease of inflammation of the airways, usually allergic inflammation, and it's a disease that causes attacks intermittently of cough, wheezing, shortness of breath. Usually it's due to allergies or allergic inflammation, but not always. COPD, chronic obstructive pulmonary disease, is an umbrella diagnosis that includes both chronic bronchitis and emphysema. It tends to be an irreversible and progressive disease that leads to disability and early death, and it's most commonly caused by cigarette smoking, although we're understanding now that in approximately 15 to 20% of cases, there are other contributing factors. So both of these diseases have immense morbidity. Asthma is very common. It's the most common chronic respiratory disease in children. It affects 9% of children, 7% of adults. Asthma is the most common disease that causes missed school days and has an enormous impact on education for children who suffer from this disproportionately. COPD is a huge public health issue. It affects 24 million Americans, and it's the third leading cause of death in the United States, and the only one of the top 10 causes of death that has not shown a decline, and in fact has shown an increase over the last 2 decades. Since the year 2000, since the turn of the century, COPD has transitioned from a disease of men to a disease of women, and more women die of COPD than men, and more women die of COPD than breast cancer by a factor of nearly 2. So the ACRC was established in 1999, and this was initially a consortium of Lung Association regional sites across the United States who came together to conduct research in asthma. And the mission of the ACRC, as Norm mentioned, is to conduct practical research that gives answers to questions that are important to patients as well as their caregivers. In this last year, because of the recognition that COPD was an important and under investigated disease, the ACRC expanded its mission and acquired a number of new research sites, including some of the top investigators in the country, to expand its portfolio to study COPD. And with that, we changed the name from the American Lung Association Asthma Clinical Research Centers to the Airways Clinical Research Centers, still using the acronym ACRC. This map shows all of the centers in the ACRC, and as you can see, they are geographically dispersed across the United States. The ACRC is organized now with 17 centers. The Data Coordinating Center is in Baltimore at Johns Hopkins. And one of the things that's been very gratifying working in the ACRC is that we have investigators who represent many, many disciplines, including basic scientists, pulmonary physicians, clinicians, allergists, pharmacologists, community health experts, psychologists, statisticians, epidemiologists, and some very skilled nurses and nurse research coordinators. The American Lung Association has really stood up this group of investigators through core support, which provides a small amount of salary support for the research scientists as well as the research coordinators. And this enables the group to go to the National Institutes of Health, to go to pharma and say, we can do these studies, we have the organization, we have the infrastructure, and now we need your support. And we have been very successful in doing that and have gotten funds from NIH and pharmaceutical companies to complement the Lung Association contributions. So the vision that we have for this network is to conduct research that's practical and that's important. And we have investigated, as you'll see when I go through some of our studies, we have investigated both traditional and alternative approaches to treatment. We want to use the data from clinical research to inform basic research, and we have included diverse populations. As was mentioned, support from the American Lung Association has been leveraged by external funding. So what are some of the things we've done? Well, I don't have time to go into it in great detail, but this is a list of some of the studies that we've undertaken. For example, one of our first studies was based on the feeling that was actually supported by some evidence that many patients with asthma had a worsening of their asthma after getting flu immunization. And we were able to show that this indeed was not the case, that flu vaccine was helpful for patients with asthma, that they could develop antibodies, and that did not worsen their disease. So this has led to stronger recommendations from From the Cochrane review, for example, that flu vaccination is important for patients with asthma. We've studied low-dose theophylline in asthma. This is a very low-cost alternative, and we've shown that it's effective in the treatment of asthma. It's not as effective as some other treatments, but because of its low cost and its ease of use as a single once-a-day oral drug, has found itself to be very useful in developing countries where a majority of asthmatics are treated with it. One of the things that we've been able to also show is that the common use prescription of proton pump inhibitors for the treatment of asthma without heartburn, so-called silent reflux, does not improve patients' asthma control. And this has enabled hundreds of thousands of patients to dispense with this unnecessary treatment. We've had our psychologists develop educational strategies using social learning theory that has shown that the way that physicians present to patients how a drug works actually can improve adherence to treatment and improve asthma control. Soy, as a dietary supplement or one of the chemicals, isoflavones, has been shown to be effective in animals for reducing allergic inflammation, but turned out not to be helpful in asthma. I just will touch on a couple other things. First of all, CPAP, continuous positive airway pressure, has been useful in reducing the irritability preliminary studies, but we have shown that this is not an effect of the pressure in the mask. We think it's a result of the humidified, filtered air, and this has led us to initiate other studies to investigate this. Finally, doctors are very good at starting treatments, but they're not very good at tapering or stopping treatments or reducing the level of treatment. And indeed, we've had two major studies that have investigated this and shown safe approaches to tapering down treatment for patients with asthma. We have a number of studies that are on the boards that we're pursuing in various stages. It can take a number of years between the concept and the execution and completion of a study, but these involve the diagnosis of anxiety and depression in COPD, where we now have a method of doing that. We are starting an early phase of a study using yoga breathing and meditation for COPD, and the preliminary trial for this has been very encouraging. We also recognize that many patients have both asthma and COPD that overlap, and yet there's almost nothing known about how to treat these patients, so this is an area we want to approach. We also believe in individualized treatment, and with new biologic treatments, we're investigating using a targeted antibody approach for patients with allergic type inflammation who also have COPD. Chronic cough is a very distressing disorder that's very common. There have been no drugs that have benefited patients for this indication since 1954, approved by the FDA, and with some preliminary data, we're planning to investigate whether zinc supplements might help this. And then finally, we have two applications in to study the effects of lifestyle and pharmacologic approaches to weight loss in patients who have asthma. So overall, I think that we've shown a very diverse approach to obtaining clinical information about how best to approach asthma, and that indeed over the last 20 or so years, the ACRC has made a substantial difference in the way we care for our patients. Thank you.
Bob, thank you very, very much for that presentation. I'm sure you'll be around to answer questions, and I'm sure there are many questions about that really large portfolio of research. Now it's my great pleasure to introduce to you Dr. Eric Collison. Dr. Collison is a medical oncologist who is an associate professor at the University of California, San Francisco. He has a special interest in the genomics of cancer. Most importantly to us, Dr. Collison is a 2015 American Lung Association Lung Cancer Discovery Award recipient, and it's my pleasure to invite him to tell you a little bit about the exciting research he's doing which merited that award. Dr. Collison?
Great. Thank you. Thanks so much, Dr. Ellman. That's a nice introduction. I'm hoping I am projecting okay and that everyone can hear me. I've provided slides, but I want to walk you through some of the problems we face in lung cancer in the clinic, how the community of lung cancer oncologists, surgeons, and supportive professionals are trying to personalize treatment with lung cancer, much like the approaches Dr. Wise described to you with inflammatory diseases of the lung. And then I'd like to drill down and give you a personal vignette of how this ALA award has really helped, I think, move the needle a little bit forward on personalizing treatment for these patients. Excuse me. So, whoops, that went backwards. I'm sorry. So everyone has probably heard quite a bit about gene sequencing in cancer and sequencing whole genomes and the wonderful results we've gotten with certain therapies like erlotinib and crizotinib, which are targeted towards specific aberrations in the tumor, the lung cancer genome. And those are easy press pieces to write, but the scientific problem is actually much more difficult. Due to the background mutation rate induced by tobacco smoke and other carcinogens, there are actually thousands of mutations in every lung cancer genome. There are 20,000 genes in the genome. Most of the mutations, as you might imagine, do nothing. They're merely collateral damage that are not causative. We call those passenger mutations. But they are very hard to distinguish from the mutations that are actually causing the cancer. And while this may sound like an academic exercise that doesn't have clinical relevance, I would stress that it really is quite the opposite. And the reason for that is if we are able to find that one mutation that's causing the cancer to proliferate, that's our first step in designing a customized therapy. So if we have 100 mutant genes in one lung cancer patient, we can't treat the patient with 100 different drugs, even if we have them, which we don't. We can't develop 100 new drugs at one time because we don't have the resources or the attention span to do that. We need to understand what's driving the cancer, to design a therapy for that, and then apply it and see if it works. So I'm going to tell you about how we distinguish those driver from passenger mutations in this presentation briefly, and then tell you how the work that the Lung Association is funding in my lab is trying to add to those lists of potentially actionable, druggable gene aberrations in lung cancer. So a lot of the background for this work was actually federally funded by the Cancer Genome Atlas, a joint endeavor between our NIH's National Cancer Institute and the Genome Institute. And I think this talk will hopefully be a good example of what Dr. Ellman referred to as a niche in a lever. And what the federal government is good at is funding big projects that kind of make very fundamental discoveries but are not immediately applicable to patients suffering from the disease. And I think that's the case in the Cancer Genome Atlas, where we learned a lot, which I'll tell you, but to get it over the goal line and to get the findings clinically relevant, we need to have individually focused research projects like the one I'll tell you about. So through a lot of work, we were able to profile 630 lung adenocarcinoma samples in great depth. We sequenced the whole genome of each of these. We sequenced the germline genome, the genes that the patient was born with. And we compared them among many other analyses that are summarized in this slide. If you're not looking on the web, you don't need to. I'll describe them verbally. The process was to obtain a tissue sample. Over 5,000 tissue samples were screened. 630 made it all the way to the end of the road, but they were made sure the diagnosis was correct, the quality was good, et cetera, through a detailed quality control process. And then we got this to a couple publications in very high-profile journals. So, whoa, this seems to have turned into another language. The next slide was just meant to show you the data flow where, since this was a federal project, it certainly wasn't my lab. It was hundreds of scientists working on this project to produce the basic data that was then sent to other computational centers to interpret those data, and then the data were presented to the scientific public. And I was proud to be a part of the producing body, and now I'm also even more excited to be part of the user group, those physicians and scientists who are using these data to change how we care for patients. So what are recurrent mutations in cancer, and what did we find? If you're looking on the web, you'll see what we call an oncoprint. Each line here, or row, is a specific gene, and each column is a specific patient. So some patients have mutations in genes denoted in green. Others have mutations in other genes denoted in purple. You're not expected to memorize this slide or to understand it, but the point of the slide is to convince you that each lung cancer patient really is unique, and that they all have different collections of mutations, and that the one-size-fits-all approach to treatment therapy is probably not right. And we have a couple of examples to this statement already. The observation that erlotinib is extremely beneficial, much better than chemotherapy, in patients with EGFR mutations in lung cancer, I think is a starting point. It's only about 10% of patients who benefit from that right now, but we look at it as a strong stake in the ground that we can begin to build a tent with and treat all patients in a personalized manner eventually over time. So after that deep characterization of 630 lung cancer genomes, one thing we found that was surprising were recurrent mutations, so mutations that happened in many different lung cancer patients in a different kind of gene family called the SWI/SNF genes. Strange name, but important genes. These genes are their job in the cell is to make sure that the rest of the genome behaves. So these are kind of caretaker proteins that package all our DNA and make sure it doesn't get hurt and gets read at the right time. It's easy for me to say, and it may not make a lot of sense, but that's because we don't really understand what these genes do, and we certainly don't understand why they're mutated in cancer. But they're mutated in quite a few lung cancer patients. If you're looking at the slide, you'll see that almost a third of patients have mutations in these genes. And to date, we're really not sure what they do. So this is another slide that is meant to convey to the audience that these genes don't work alone. The SWE/SNF genes encode proteins that come together and form a molecular machine. So there's many different genes that stick to each other and form a molecular machine that combs over all the DNA in the genome, makes sure it's behaving properly, and is being transcribed and read when it should. So with this, the finding of mutations in these genes was somewhat surprising because we didn't know when we first saw the mutations how to even think about what they might do. Other genes like the EGFR, we know that they are important in controlling growth. So when we saw them mutated, we said, hey, I bet that's an activated gene. I bet it turns on and won't turn off, and it makes the cell grow. And that turned out to be true, and making an inhibitor of that turned out to be successful. And that was a great story, but it didn't really scale in this setting. As Dr. Ellman put it, there was no lever there, and we couldn't immediately figure out what to do about these mutations. So I wrote a proposal to the Lung Association and said, maybe if you guys give me a little bit of support, we can take a year or two and put these genes into the laboratory mouse, cause lung cancer, which I had convinced them we could do using techniques we've published before, and then take findings directly from patients that we discovered in the Cancer Genome Atlas and put them into the lab mouse or not, and compare the tumors that came out of those mice who gave their lives for science in the study of this gene family. And I think those reviewers thought that they agreed that this was a family of genes that is telling us it's important by its high mutation rate. There aren't many genes that have a 30% mutation rate in cancer. And no one on the review committee seemed to know what they did either, so they thought that it may be, if they didn't know and I didn't know, maybe we should try to figure it out. And so that's what we did through about a year of work now almost. And this is a Kaplan-Meier curve to show that when you knock this gene out in the mouse, the mice do not live as long as if you keep the gene intact, so it leads to a more aggressive cancer. The cancers have some characteristic morphology under the microscope that we think is important, and that in cells derived from these cancers growing in a dish in the lab, in the incubator, we can show exactly biochemically what genes this mutation is causing to be overactive. So what I think we are at this point in the research is that we have a model that we can ask questions with that is otherwise very quiet. And that's important because, remember, lung cancer, although smoking is decreasing in this country, lung cancer is still largely a disease of smoking. There are thousands of mutations in these genomes, and telling one from the other is difficult. So we've created a system with only this abnormality in it, and in the next year we're going to use that to study exactly what changes these mutations invoke. Something that's exciting and directly empowered, again, using the lever Dr. Ellman told us about, is depicted on this last slide. You're not supposed to understand all of this, but these blue bars and red bars show what we can do with these cells when we get a drug that our collaborators at Genentech have made that they think binds to this same protein. So this is a direct example of we made this model. The drug company needed it and found it interesting. They shared their preclinical compound with us, and we're beginning to work together to see if there's a path towards clinical development in patients with mutations in these genes using these very early compounds. There's drugs like this don't exist in medicine yet. They're called bromodomain inhibitors. They're a totally new class of drug. They don't kill bacteria. They do not cause your heart to beat up or your blood or your blood pressure to go down. They bind the caretakers of the genome directly. So it's a really interesting new class of drugs that may allow us to control gene transcription using small molecule pharmaceutical drugs. So I know that that has been a bit of a whirlwind, but the overarching story I wanted to tell you was how taking data from a large federally funded genomic consortium, putting it back into the laboratory in a single lab focused on a single problem can really make a lot of progress in a specific way. So it's imperative in biomedical research that we have both federal support to do big projects that can't otherwise be done. The analogy would be building the Interstate 10 freeway. That's an important task for the federal government to do. But just as important, obviously, is building the side roads and going deep into the mountains and down to your favorite stream that may not be the interest of Washington, D.C., but are obviously worth the drive. I'm going to end my presentation to leave time for questions, but want to remind us that the next frontier in this kind of genomic research, I think, is studying the process of metastasis. All the data I've shown you is from primary lung cancer, that starts and stays in the lung. But really what kills patients is the spread of this disease to the liver and elsewhere, and that understanding the gene transcription that causes that may allow us to prevent that event even in patients diagnosed with the disease. So with that, I will give it back to Dr. Ellman and welcome questions if they arise, but really want to thank all of you for your support and the Lung Association for such responsible stewarding of those resources. Thanks.
Thank you very much, Dr. Collison. That's very exciting, and the American Lung Association is quite proud to be sponsoring research which finally begins to offer some real hope for the effective treatment of lung cancer. I'll now turn this over to Erin, who will moderate the question and answer session.
Thank you so much, Dr. Edelman. And we did receive a question for you, Dr. Collison. What is currently being developed to deal with the EGFR and T790M mutations once they become resistant to both Tarceva and Tagrisso?
Good question. So the question refers to one of those genes, EGFR, that we talked about. This has been a fascinating story. We're all medical oncologists who treat this, but this is becoming much like HIV treatment in the 90s. For the audience who remembers those days of the AIDS epidemic, there was literally no treatment for HIV beyond a single drug called AZT. That drug knocked the HIV virus down for about a month to 2 months, and it came roaring back. And that process was called acquired resistance. It always happened the same way. The virus got a second mutation and learned how to not bind to the AZD drug anymore. I'm sorry, AZT as in Tom drug. So Dr. David Ho and others around the late 90s figured out that if they used 2 drugs or even 3 at the same time, they could prevent that resistance, because it's really a math problem of how the virus needs to replicate to find resistance, and if it can't replicate, it can't find resistance. And we're beginning to, we've had some success with erlotinib knocking down EGFR mutant lung cancer. That works for 6 months, 7 months, a year and a half. Resistance always occurs. And when that comes back, it's very frequently due to that mutation T790M. So that's one gene with 2 mutations in it, just like the HIV virus. And AstraZeneca recently made a second drug, Tagrisso, that was mentioned, that is effective against that T790M variant. But we're now, just like the HIV experience, finding 3rd mutations in the same gene that cause resistance to Tarceva and Tagrisso. And so I'll answer the question by saying the best way to treat resistance is to prevent it, okay? Just like cancer, the best way to treat it is to prevent it from occurring. And so we're looking at combinations of drugs, much like the combinations of HIV, to prevent resistance from occurring. Now, once it has occurred, it's a tougher problem. We're looking to immunotherapy in those cases, or even more sophisticated drugs that bind to the EGFR in an even newer way. But it's a tough problem. I don't have an easy answer for that. Does that make sense?
I think so.
Good.
And actually, there was a question that came in for both of you, Dr. Wise and Dr. Collison. And so, Dr. Collison, you first. What motivates you to study this type of research? What was the defining moment you knew that you'd pursue the answers to lung disease?
For me, it was really a spectrum. When I was in medical school, I was lucky enough to be sitting there while the first generation of these therapies for a form of leukemia actually were developed in the mid-2000s, and that was so exciting. I really loved that. And then I'm like, well, only 1,000 people get this disease every year after I kind of looked into it, a rare form of leukemia. And when we began seeing responses in lung cancer, solid tumors that were analogous to these Lazarus-like responses in leukemia, it was really too good to be true for me, and it's really a privilege to get to work with patients and do this kind of science at the same time. It's like best of both worlds.
That's fantastic. Thank you so much for all the work that you do for research, as well as the work that you do with the American Lung Association. We are so appreciative. Dr. Wise, I know that you've been working with the American Lung Association for some time, and to that same question, what motivates you to study this type of research with asthma and COPD, and did you have a defining moment when you knew that you'd like to pursue?
Yeah, I think it's been more of a pathway than an epiphany for me, but I think back, and when I was a third-year medical student, one of my very first patients on one of my very first rotations on the ward was a man who was suffering from respiratory failure from COPD and had heart failure as a result of that. And I can clearly remember to this day, some 40 years later, staying up all night with this man who couldn't breathe and was breathing on a positive pressure machine, and in the morning he slipped into a coma and died. And that was a very wrenching experience for me. And as a few years later, during my residency, I got to see some of the very first respiratory care units and seeing how we really could make a difference in the lives of people who were suffering from advanced COPD. And and extend their lives and improve their lives. And I haven't looked back since. I've been working on that same principle.
Thank you so much, and it is so important, the work that you do for everyone affected by lung disease. Dr. Edelman, you as well have been working with the American Lung Association for quite some time, especially in our research programs. Why is it so important to fund young investigators?
Well, young investigators are our life's blood. As you can see from these presentations, research is complicated, it's long, it's hard, it's inspiring. It attracts these wonderful people, these two people you've just heard. But it's something that has to keep continuing. It's something that has to be passed on from one generation to another. And we have to make sure that there is a new generation of interested, exciting, intelligent, bright people. And they need help. They need help developing their careers, which is mostly what we do. And they also need help in sustaining their careers, which has become an increasing challenge. And it's one of the reasons why the American Lung Association is now venturing into the established investigator awards, because we need to keep those people going as well. Without new blood, research simply stops. And for us to really conquer these diseases, research must go on.
Thank you so much. And one final question that we received today to Harold Wimmer. Mr. Wimmer, going forward, what are the goals for the American Lung Association's research portfolio?
Well, the American Lung Association is really focused on expanding our award categories that we currently operate through our program, including our awards and grants, our ACRC, our Lung Cancer Discovery Awards, and our brand new award, which is funded through our new Lung Force initiative that is aimed at lung cancer in women. And, over the last 10 years, the American Lung Association has been able to invest close to $70 million into funding research projects. And over the past few years, we've been able to increase the number of projects that we're funding. Last year, we funded 69 separate research projects within those categories. And our goal is to significantly increase the number of research awards that we're able to provide on an annual basis. And we're looking to do that by raising new resources from our supporters. We're also looking at leveraging the dollars that we're investing into research. And currently, out of the 69 projects that we're funding, 30% of those projects are co-funded with other organizations, either private or government agencies. But our goal is to get 100% of our research projects co-funded. And we feel that we'll be able to really leverage the precious dollars that we're able to raise to support research through this mechanism. And also, what's really key for the American Lung Association in the area of research is not only funding our association program for research, but is also to advocate for more federal support for research. Last month, the American Lung Association hosted our Advocacy Day in Washington, D.C., where we met with our congressional leaders and asked them to support increasing funding for the National Institutes of Health to a level of $34.5 billion. And so, we feel that it's very important that we get increases in federal funding for research, which really helps everyone through this process. So the American Lung Association is using a multi-pronged approach, and our goal is to significantly increase the dollars that we have for research, because I think, by the presentations that we heard today and through the history of the Lung Association, we can really see the type of impact that research has on lung disease.
Thank you so much, thank you so much, Harold. We really appreciate it. And thank you to everyone who joined us on today's call.
Well, Aaron, I'd also like to thank everyone who joined us on today's call. I hope you found it as informative as I did in hearing the updates, and I'd like to thank Dr. Edelman, Dr. Weiss, and Dr. Collison for spending their time and for being a part of the American Lung Association research team. Thank you very much.
Thank you all.
Have a great afternoon. At this time, we will end our presentation, and we look forward to reaching out to you soon with more information about our research. For more information about all of our research programs, you can find them at lung.org/research. Thanks so much.